Welcome everyone. In this video, I am going to highlight or recall some of the important concepts related to the topics that we already have discussed in our previous videos. These concepts will help you to solve questions directly which are memory based or concept based. So make sure that you watch the video till the very end. This is a miscellaneous video in which I have tried to cover all kind of topics, right? So you will find that it is not a very consistent one. It is all about the facts or concepts that we use to solve the multiple choice question. So let's start. First point is, a random variable is called a discrete random variable if its set of possible outcome is finite or countably infinite. So this question is asked in MCQ that a discrete random variable can take what kind of value. So it can take either finite value or countably infinite value. So this should be kept in mind. Second is that the discrete random variable satisfies these two properties, that probability of x should be greater than or equal to 0 and sum of probability for all value of x should be equal to 1, right? Cumulative distribution function or distribution function, which we represent by f of x, is defined as f of x is equal to probability of the random variable up to the value x, right? Problem based on this I have discussed in my main video, so in case if you want to watch that, you should certainly watch that in the playlist. Now let us talk about continuous random variable. So this is an important MCQ question, that when we talk about continuous random variable, for a continuous random variable the probability at a point x is equal to 0 for all value of x. So for continuous random variable, if I ask you that what is the probability at a particular point alpha, so in that case the probability is equal to 0. Very important point. Second important point, that if you look at the continuous random variable, in case of continuous random variable, probability is calculated in an interval. So probability for x taking the value in the interval a to b open, or at a closed at b open, or in this interval, all of them are equal, and that is just probability is calculated by integrating f of x between the interval a and b, where f of x is known as the probability density function. And this is also the characteristic that the continuous distribution satisfies, that if f of x is a probability density function, then f of x should be greater than or equal to 0, and integration of f of x from minus infinity to infinity should be equal to 1. Here the interval we take is the the possible interval in which the x can take its value. Okay. Now cumulative distribution function in case of continuous random variable is defined as, the definition remains the same, probability of x less than or equal to x, and in this case we integrate the function from minus infinity to x, and then we integrate the probability density function. It is also a important MCQ question, that in case of continuous probability distribution, if I have to find the probability in an interval a to b, this is f of b minus f of a, where this f capital F represents the cumulative distribution function. Okay. Now this is a very important slide, and you should watch this very carefully. And what it tells you that the mean or expected value of a random variable x. So what is the mean? Mean is represented by mu, which is also known as expectation of the random variable x, and that is equal to x into probability of x, or x into f of x, where this represents the probability distribution. In case of discrete, in case of continuous, the mean or expectation is calculated by integrating the x into fx term in the interval minus infinity to infinity, and here the interval is taken as the largest possible interval in which the random variable can take the value. Then we define something called as variance, and variance is defined as expectation of x square minus mu, which is nothing but expectation of x whole square. On this definition, lot of questions are asked in multiple choice, so keep this in mind. Now there are certain properties, and based on these properties also questions are asked. The first property is that if x and y are random variable, then expectation of x plus y is equal to expectation of x plus expectation of y, and expectation of ax plus b is a times expectation of x plus b. Second property is that if x and y are independent random variable, and I highlight the independent, then expectation of x into y is expectation of x into expectation of y. And this is the most important property, that if x is a random variable, then variance of ax plus b is equal to a square into variance of x. So based on this definition, sometimes they directly ask the question. For example, they may ask you that what is the variance of 3x plus 2. So one of the options will be 9 times the variance of x, because this a when comes out becomes the square, right? So this property should be kept in mind. Covariance of two random variable x and y with mean mu x and mu y is defined as, so covariance is defined as expectation of x into y minus expectation of x into expectation of y, where expectation of x is also represented by mu x and expectation of y is represented by mu y. Chebyshev's theorem, it is an important result, and it tells you that the random variable x, the probability in the interval mu minus k sigma to mu plus k sigma, where mu is the mean and sigma is the standard deviation. So in this interval, the random variable will take its value, its probability is greater than or equal to 1 minus 1 by k square, right? So if I take k is equal to 2, it means what? That probability that the random variable will take its value in the interval mu plus 2 sigma and mu minus 2 sigma, that will be greater than or equal to 1 minus 1 by 2, that is 3 by 4, right? So based on this, if they ask the direct question, you can answer. Moving forward, I'm going to talk about some concept related to correlation and regression, and all these concepts that I am going to discuss are very important. They ask a lot of questions based on this. So the definition: positive or direct correlation, if the increase in one results in the corresponding increase in the other, then it is called positive correlation. Or if one decreases, another also decreases, then also it is called positive correlation. When do you call it a negative correlation? If one increases, other decreases, or one decreases, other increases, then it is called the negative correlation. Keep that in mind. The Karl-Pearson coefficient of correlation gives us the measure of linear relationship. They may ask you this question, that Karl-Pearson coefficient of correlation gives what kind of measure? So it gives the measure of linear relationship between the two variable x and y. And how it is defined? It is defined as covariance of x and y divided by sigma x into sigma y. You just have seen that covariance is nothing but expectation of x and y, x into y minus expectation of x into expectation of y divided by sigma x sigma y. How it is evaluated? For that you can watch the main video. There are a list of properties that I have highlighted here, and all of them are very popular for multiple choice question. The first one I already have told you, that the correlation coefficient is a measure of linear relationship between x and y. For non-linear relationship, this is not very suitable. Second important point is that Karl-Pearson coefficient of correlation is also known as product moment correlation. Keep that in mind. This is one of the most important property, that correlation coefficient takes its value between -1 to 1. If R is equal to -1, then correlation is said to be perfect and negative. These are facts you need to keep in mind. If R is equal to +1, then correlation is said to be perfect and positive. This is a very important property, that correlation coefficient is independent of change of origin and change of scale both. I highlight it, both. Correlation coefficient is independent of change of origin and change of scale both. Another important property is that correlation coefficient between two variable ax plus b and cy plus d is nothing but ac by mod of ac and correlation coefficient between x and y. So they may give you problems that find the correlation coefficient between 3x plus 5 and 7x plus 9, right? So what will be the correlation coefficient? That will be 3 into 5 by 3 into 7. The A is 3, C is 7, so 3 into 7 by 3 into 7 mod, and then the correlation coefficient between x and y. So they may give you the correlation coefficient between x and y and may ask you the correlation coefficient. Now this is another important property, that two independent variables are uncorrelated, right? Two independent variables are uncorrelated, but two uncorrelated variables need not necessarily be independent. So keep these properties in mind. This is also sometimes asked in multiple choice question, which is known as the probable error of correlation coefficient, and it is defined as, now first of all we define something known as a standard error. So a standard error is defined as 1 minus r square by under root n, where n is the number of observation or number of pairs of observation, like how many pair of x and y's are given, that gives the n, and r is the correlation coefficient. So they may give you that if the correlation coefficient is this, find the standard error, or directly they may ask you what is the formula for a standard error. Now similarly the probable error is defined as 0.6745, keep this in mind, into the standard error. So this will become 0.6745 into 1 minus r square by under root n. If r is less than the probable error, then correlation is not at all significant. We can say that there is not much correlation between two variables. But if r is greater than 6 times the probable error, then the correlation is definitely very significant. Okay. Next thing is rank correlation. In rank correlation, I am not going into the detail. Keep this formula in mind, that 1 minus 6 times summation of di square by n into n square minus 1, and summation of di is always equal to 0, right? For a repeated rank case, the formula changes into 1 minus 6 times summation of di square plus the correction factor. What is the correction factor? Correction factor is calculated by m into m square minus 1 by 12, where m is the number of times an item is repeated. To get more about this, watch the video of rank correlation. Moving ahead, the lines of regression. So this is the line of regression of y on x, and this is x on y. So how do you write the normal lines, normal equations? Normal equations for line of y on x is summation of y n into a plus b into summation of x, and then you multiply this by x into y summation, and you write a into summation of x plus b into summation of x square. I am doing it fast so that we can summarize the video quickly. For this, the normal equations are given by summation of x is equal to n into a plus b into summation of y. We take summation in both sides, and then we multiply it by y and take the summation. So summation of xy is a into summation of y plus b into summation of y square. Using this, we can also conclude that summation of y by n is equal to n into a by n plus b into summation of x by n. So summation of y by n is y bar. This is a plus b into x bar. So we note that the point x bar, which is the mean of x, and y bar, which is the mean of y, this lies on regression lines, right? So if two lines of regressions are given and they ask you that find the mean of x and y, so you just need to solve these two lines of regression to get the value of x bar and y bar. The point where they intersect, that point is the point ordered pair, like the first gives you the mean of x, then the second gives you the mean of y. This kind of questions are asked, so please check the previous video, the main video, to get better about this. Okay. Moving ahead, another form of regression line is given by y minus y bar is r sigma y by sigma x into x minus x bar, and this r sigma y by sigma x is known as byx. So that is the regression coefficient of y on x, right? Byx. And similarly, the regression line of x on y, so x minus x bar r sigma x by sigma y, y minus y bar, and this bxy is known as the regression coefficient of x on y. So there are certain properties of it which are useful and may be asked in MCQ question. So remember this. Correlation coefficient is the geometric mean between the regression coefficient, and the sign of regression coefficient and the sign of correlation coefficient is same, means R is equal to plus minus under root byx into bxy. So when the regression coefficients are given, we can find the correlation coefficient, and all of them will have the same sign, means if byx is positive, then bxy will also be positive and R will also be positive. Second property is, if one of the regression coefficient is greater than unity, other must be less than unity. Very important property. Third property is that 1 by 2 byx plus bxy mod will be greater than or equal to mod R, where R is the coefficient of correlation. And fourth property is very important, that regression coefficient are independent of change of origin but not of a scale. If you have seen the previous slide where I was talking about correlation coefficient, I told you that correlation coefficient are independent of change of origin and change of a scale both, right? You see it is written that correlation coefficient is independent of change of origin and scale both, but regression coefficient is independent of change of origin but not independent of change of scale, not of scale. So keep this in mind. This kind of question has been asked multiple times, that if R is equal to 0, then angle between the regression line is 90 degree, pi by 2. So it means what? That if two variables are uncorrelated, then the line of regressions become perpendicular to each other. They may ask you that if R is equal to 0, then the regression lines will be, and the answer is perpendicular to each other. If R is plus minus 1, in that case the line the angle between two lines of regression is either 0 or pi, but we know that two lines of regressions can't be parallel because they intersect at point x bar comma y bar. So in case of perfect correlation, positive or negative both, the two lines of regression coincide, means they lie over each other. So what is the first point? When there is no correlation, the lines are perpendicular to each other. When there is a perfect correlation, means R is equal to 1 or R is equal to minus 1, in that case two lines lie over each other, means they coincide, they are just lying over each other. So this is another important property. Okay, moving ahead. So we talked about correlation and regression. Now we are going to talk quickly about the distribution, a special kind of distributions. The properties of correlation and regression that I have discussed, certainly some question may be asked. One thing I missed to highlight, that rank correlation row also lies between -1 to 1. So that should also be kept in mind. Now Bernoulli process, these are four important terms which you need to keep in mind. I pause this video, take the screenshot. That experiment consists of repeated trial. The trials result in an outcome that may be classified as success or failure. The probability of success denoted by P remains constant in each trial, and the related trials are independent. So sometimes they ask that which of the following are the requirement for Bernoulli process. So this may be a direct MCQ question. Okay. Next is binomial distribution. So I'll be speaking slowly because some questions may be asked directly on this property. So listen very carefully. So I will be highlighting some of the points and I will not be writing. So listen carefully and note it down. Point number 1. Binomial distribution is a discrete probability distribution. Point number 2. The probability distribution is given by NCX p to the power x q to the power x n minus x. Point number 3. In case of binomial distribution, the random variable can take value from 0 to n. So if we are performing n number of trial, the number of the possibilities that x can take value is 0 to n. Point number 4. That mean of the binomial distribution is n into p. Point number 5. The variance of the binomial distribution is n into p into q. One point I missed, that the parameters of binomial distribution are n and p. Because if we know n and p, we can get the probability, because we know that in case of binomial distribution, p plus q is equal to 1, right? So n and p are known as the parameter, and if we know n and p, then we can calculate q also, and then we can calculate probability for any value of x. So that is why these are known as parameter. Point number 7, there is a relation between mean and variance. What is the relation between mean and variance? That mean is greater than variance. Why mean is greater than variance? Because mean is np, and what is variance? Np. So in this we are multiplying by q. So q is a quantity which is less than 1 and greater than 0, means q lies between 0 and 1. So if you multiply something by less than 1, it will become a smaller. So np, so mean is greater than variance. I repeat, point number 1, binomial distribution is a discrete probability distribution. Point number 2, the probability distribution is given by this function ncx, p to the power x, q to the power n minus x. Point number 3, that parameters are n and p, and p plus q is equal to 1. Point number 4, mean is np, variance is npq, and mean is greater than variance. So this information should be kept in mind. What is negative binomial distribution? Negative binomial distribution is also a discrete probability distribution, and that probability distribution is given by x minus 1 ck minus 1 p to the power k q to the power x minus k. So it gives us the probability of x number of success in k number of trial, and the random variable x in this case can take value from k to infinity, k plus 1 up to infinity, right? The geometric distribution is given by p into q to the power x minus 1, where p is the probability of success, q is the probability of failure. Geometric distribution represents what? It represents the first success, probability of first success in the x number of trials, right? There are many other properties that I will be discussing in the next part. Poisson distribution, again very important. Point number 1, Poisson distribution is a discrete probability distribution. All the probability distribution, binomial, negative binomial, Poisson and geometric distribution are discrete probability distribution. For Poisson distribution, second point is that it is a limiting case of binomial distribution. It is a limiting case of binomial distribution. Under what condition? When n, the number of trials, is indefinitely large. You have to keep this in mind. Sometimes they ask this. When p is very small, tends to 0, and np is equal to lambda is finite. What is the parameter of Poisson distribution? The parameter of Poisson distribution is lambda. And what is the probability distribution in case of Poisson distribution? It is given by the function e to the power minus lambda, lambda to the power x by factorial x, right? What is the mean? Mean is equal to lambda. What is the variance? Variance is also equal to lambda. What is the relation between mean and variance? The mean is equal to variance. So all these are very, very important characteristics. Moving ahead, the moment generating function. So the moment generating function is nothing but expectation of e to the power tx. Sometimes they ask this directly. In case of continuous probability distribution, this is the formula, integration e to the power tx f of x dx. In case of discrete, e to the power tx f of x for discrete probability distribution. Now, in the last video that I uploaded related to the moment generating function, there are certain things and which I want to highlight. So the first is that what is the moment generating function for binomial distribution, and you have to keep this in mind. They ask this. So for binomial distribution, moment generating function m of xt is given by q plus p into e to the power t to the power n. Point number 1 means for binomial. What is for Poisson? For Poisson, it is given by mxt, the moment generating function is e to the power lambda into e to the power t minus 1, right? In case of negative binomial distribution, the mean and variance discussion I already have done. So in case of negative binomial distribution, the moment generating function is given by p into e to the power t to the power k divided by 1 minus q e to the power t to the power k, and here it is expected that q e to the power t mod will be less than 1, because otherwise it will not converge. Ignore this if you didn't understand, just keep this in mind. One point I missed, that what is the mean in case of negative binomial distribution. Mean is k by p, and what is the variance? The variance is k into q by p square, right? So the mean is k by p and variance is k into q by p square. So this is for negative binomial distribution. Remember this, remember this, remember this. What is the moment generating function for geometric distribution? It is p into e to the power t divided by 1 minus q into e to the power t. And if you remember, I might have discussed in the previous video that geometric distribution, this is for geometric distribution. Geometric distribution is just a special case of negative binomial distribution, in case when we take k is equal to 1. So you can see from here itself that if you put k is equal to 1, you will get this, right? And what is the mean in case of geometric distribution? Mean is equal to 1 by p, because k by p is the mean in negative binomial distribution, and k we take 1, so it is 1 by p. And what is variance? So variance is, we take k is equal to 1, so it is q by p square. So all these things that I have discussed are very important thing. This is a very short video, but not very short, means 26 minutes, but short as per my standard. But I would request you that whatever facts I have discussed in this video, that should be kept in mind, because questions, maybe 30 to 40% of the questions can be asked from whatever I have just discussed. This is my estimate. I don't know what will be there, but this is what we are expecting. So this is all in this video. Thanks for watching. Next video I'll be solving multiple choice question. Make sure that you share with everyone so that it reaches to the maximum student, and ask them to subscribe the channel as well. Thank you.